Welcome. In this video, we're going to talk about the concept of mass percent, which is something that we will see show up in various contexts throughout the year. And we're going to start with the example of looking at the mass percent of an element in a compound. We're going to use that as a way to practice this mass percent idea. So the whole idea of percent by mass, just like a percent in general, it's the way you find a percent is you take the part divided by the whole times 100. So if we're looking at percent by mass, that means you take the mass of the part divided by the mass of the whole thing and multiply that by 100 to give you a percentage. We're going to be looking at, in this example, the percent composition of an element in a compound. In this context, then you take the mass of the part, which would be the element, divided by the mass of the entire compound, that'd be your whole thing, multiply that by 100. Here's it broken down even further. What you're going to do is you're going to take the number of atoms of a certain element times the molar mass of that element and divide it by the molar mass of the entire compound. So that's what we're going to be doing here. And you will notice that we mentioned molar mass. So this is something you will want to be looking at your periodic table for to access those molar masses. You also want to make sure you've already done the review of the concept of the mole and molar mass, which is looking at page 2 and 2A. And I will also say that you will have paper copies of periodic tables and equation sheets available at materials pickup, which they've just announced is going to be next week from the 14th to the 16th, I believe. There's specific dates and times. So when you go, if you go to pick up a textbook, there'll also be a hard copy of a periodic table if you'd like that. So I just made those copies today and have them ready for you. All right, so we're gonna look at this example. Find the percent composition of the compound sodium oxide. It's an ionic compound, it's got two elements in it. So to find the percent composition, what we're gonna do is we're gonna say what percent of it is sodium and what percent of it is oxygen. And let's look at the sodium one first. So to find the mass percent, we're going to take the mass of the sodium divided by the mass of the entire thing. And the way that we're going to find this, if we look up on our periodic table, here's our sodium. So the sodium oxide is made of 2 sodiums. So here's my sodium over here. So I've got 2 sodiums. I'm going to write it out like a addition, and then 1 oxygen over here. Oxygen weighs 16. Okay, so that is the mass of my sodium oxide. And then the mass of the sodium, keep in mind there's 2 sodiums, right? So we have 2 sodiums, so we want to, double that mass. So I am going to plug this in my calculator in real time with you. This is exciting. So we've got 45.98 grams of sodium on the top, and on the bottom we got 45.98 plus 16. So that's the molar mass of the compound. And then you multiply it by 100%, and you will end up with your mass percent, 45.98. Boom, 0.98 divided by 61.98. You should end up with 74.22. It looks like based on these values, we would have 4 sig figs in our answer. Usually we're not going to worry about sig figs in this type of calculation, but we would have 4 sig figs here. So it's 74.22% sodium by mass. So there's that. To find the percent oxygen, we should just be able to subtract 100 minus 74.22 because there's only 2 elements, and those percentages should add to 100. But it's always good to maybe double check that. So for this case, we would say the mass of oxygen divided by the mass of Na2O. The mass of oxygen is 16.00. And then let me just double check that our other one was right. 22.99 times 2 plus 16. Yeah, that seems right. Okay, 61.98, and then times 100, and that's going to give us 16 divided by 61.98. Hooray, they do match up. Okay, so this is 25 0.81% here. Cool. So there we go. It looks like they're rounding. I don't know if they quite exactly add up to 100, but that's okay. So that's how you find the mass percent of elements in a compound. Oh, something else I would want to say with showing your work, you do need to show some sort of work. You don't just want to say percent sodium is 74.22. You need to show how you got that number. But writing this is enough. You don't have to show how you added up the two sodiums and the oxygen to get the molar mass. You're going to be calculating a lot of molar masses. You do not need to write this step out every time. I just did it here to show you what I was thinking, but you can just skip straight to this step when you are showing your work. And other thing I want to talk about is what if I have a polyatomic ion? So we do a quick example. Let's say we had something like magnesium. Let's do lead 4 sulfate. Not entirely sure if this compound exists, but we'll go with it. Lead could, in theory, form a +4 ion, so this could happen. So the way that you would deal with this is you'd say, okay, I have one lead, right? And my lead weighs 207.2. And then this 2 distributes, right? So we have 2 sulfates, which means you have 2 sulfurs. So the sulfur would be, for the sulfur, it would be 2 times 32.06. And then you'd have 2 times 4, you'd have 8 oxygens. So for your oxygen, the mass of your oxygen would be 8 times 16.00. So I just wanted to point that out, how to deal with polyatomic ions and a number outside the parentheses. All right, hope this helps.